Okay, good morning, everyone. Can you all hear me? Can anyone answer me, please, in the chat? You can hear me well now? Hello? Okay, good. Thank you. Okay, good morning, everyone. Let's start our course in higher maths of partial differential equations. So I'm going to take you to, I think all higher maths people are doing the MTM as well, okay? So I will have you 4 credit courses, 2 in MTM 21212, yesterday 1, numerical analysis 1. The second one will be higher maths partial differential equation. That is also 2 credits. So as you know from our last semester, vector calculus, if we have 2 credits, we should have 4 questions in our semester, as well as I will arrange your course in 4 chapters for you to easily study for each chapters, okay, for each questions. Also, I will have continuous assessment as in the order. So we will have those things in when we meet in the physical classes, likewise, like what I said yesterday, okay. So we'll have the continuous assessment and all our exam things when we meet up in the physically, when you are coming for practical or any, any more things. So at that time we can have our continuous assessment. But now we will continue the lecture itself like this in the online mode, as well as our hello? Can you mute others? Hello? I think somebody is talking. Please mute your mic, okay? Okay, so now let's start our course, the higher maths. It's a HMM 21222. So I think you are having HMM 21212, the classical mechanics. Likewise, this one is a partial differential equation. So this is very connected to your ordinary differential equation. So you can combinedly study both. You can see the differences, but the concept is somewhat same. So you can, that is also will be helpful for you to study this one very easily. Okay. So let's see the aim of this course, which is to provide basic knowledge in the theory of partial differential equation, as well as to solve boundary value problem, which arise in the field of mathematical physics. So you can see one by one. Also, you can read through the intended learning outcomes. So likewise, I also taught you the elementary differential equation. So the same way we will start the things, okay? So likewise, I think you'll remember the things. First of all, we'll introduce you what is partial differential equation, and we'll see how to classify as per the order, degree, linear, homogeneous, like that. And there is another classification also there, linear, semi-linear, quasi. We can see everything. Okay, just go through these outcome, what we are going to study in this course. Okay, there are like solving method, first order. Likewise, in our elementary differential equation, we have studied exact method, separational method, like etc. Right? I hope you all remember and done the exam well. Okay. So likewise, we here also we're gonna find some how to solve the first order PDE by some methods. Also second order, and also use separation of variable. I think you remember the things. So that is also available to solve our some famous equations on the PDE. So those things are the intended learning outcome. Similarly, hope you all get my module I didn't upload it in the VLE because I'm having some problem in the VLE. So I hope you all get from the WhatsApp. Okay. So these are the ways I have divided this course content as per the chapters. Okay. We'll study one by one. Also, this is one of the important thing you have to take down. These references. You can find these books in our library. So even some books may be available in the online also. So if you're interested before coming here, you can also find from the online and download and study as well. So not only this one, there are many books available even online and library. So you can refer everything. Okay. Okay, let's begin our sections. So first of all, I would like to give you some little introductions. So as you all study ODE, isn't it? Ordinary differential equations. In your MTM. So we are studying both in the same time. So it will be very helpful for you to distinguish as well as the concept little bit only different. Okay. But the things is same. So it will be very easy for you to grab the things. Okay. Partial differential equation. So ordinary means, can you tell me one difference between these two? That is the main difference. Can you check me your answers? So far you are understanding from our elementary differential equation as well as the ordinary. You already had the lecture in ordinary differential equation. So can you tell me the difference, what you have understood? I think I told this answer already in our elementary differential equation course. Can someone answer me or everyone? If I'm asking some question, you can also Google if you're having your phone or anything. You can find the answer and get me the answer in any mode. Can anyone tell me what is the difference between the ordinary ODE and PDE? Why we are studying different courses? Okay, please answer me quickly. I'm waiting for your answers. Nobody answering. What's happening? From the elementary differential equation knowledge, what do you thought? What is the simple difference between the ODE and PDE? Okay, I'm getting one answer. Let me see. Yes, good. Yes, good. Okay, very good. Okay, so I think you get the idea. Okay, so it means the answers are yes, ODE independent variable 1, PDE independent variable not 2. Okay, 2 or more. Yes, someone has answers. Yes, 2 or more. Very good. Okay, so that's a simple difference. Okay, ODE always considering the one independent variable. Okay, so I mean the variable, let's say u is our dependent variable, which will be depend on one x or y or z, only one variable. Okay, this is one. If it is a partial mean what? Part of the differential equation. Okay, so partial means it will have sometime 2, sometime maybe any number. Okay, more than 2, 3, 4, 5, 6, any number. Okay, w it goes. So this is kind of the small difference between the OD and PD. So you got the idea. That's good. Okay, so we don't go much. Okay, so we'll have simplify 2 variables or like 3 variables. Okay, mostly in our discourse. Okay, so that's the idea. So let me begin the thing. Okay, so one more thing, as you all know, in the ODE, we use, because of it's a one variable, we use the du over dx or du over dy. So d is defined for the differential equation, ODE differential equation. But for the partial, we use the da bar. Okay, da bar u over da bar x, where da bar u over da bar y. Okay, or like this. We can see it later. Okay, so that's the simple introduction of PDE. Okay, and also we mostly use rather than telling P partial differential equation, it will be a bigger form, isn't it? We use ODE or PDE. Okay, it's the abbreviations. No need to tell the biggest ordinary differential equation. That rather than that ODE, partial differential equation, it has been, I mean, abbreviated. Okay, abbreviated. Abbreviate means simplify in a simple way. Okay. Okay, let's begin the course. Chapter number 1, lecture 1, chapter 1. Okay. Chapter 1 is all about the introduction and, the types, classification and everything. So first of all, so as I said, the partial differential equations itself having 2 or more variable. Here, for example, they have, mostly they take u, z, all these things to have the dependent variable mostly. Okay. It's not always compulsory, but you can go through in the exams and things. They use some like these words for the dependent variable, and x, y, z, t, sometimes that o, f also dependent variable, like the w, something like that for the independent variable. Okay, so you have to know how to find a dependent variable and independent variable as well. Okay, in this example, okay, in this introduction, they use u is equal to u, x, y, z, t. So how many dependent variable, how many independent variable? Can you answer me? Please answer quick as possible. Even 1 or 2 people is enough. But I'm expecting everyone to answer. But if I get quick answer, I can go quickly. Okay, please answer me. What is the dependent variable? What are the independent variable? And in this, okay. Can you tell me what is the dependent variable? What is the independent variable? And how many independent variables? You don't need to write a big, sentences for the answer. Just use a simple words. Yes, good. I get the answer. Yes. Very good. Okay. Some more. Let's say other people. Yes. Okay. I think only 1, 2, 3 only answering for the question. I need everyone to answer. If you answer only, it will be so fun and you will be in a correct way. Okay. Okay. Good. Okay. 3 independent variable. Not that 3. No. Can you check the answer? 24. Yes. Okay. Good. Okay. Fine. That's enough. Okay. So you can see u is we always note like this way, no? So u is, I mean, if we wanted to write like this way, this is an indication. Okay. This means u is the variable. You can write this way or this way. Simply u means this u having this much of independent variable. So u is our dependent variable and x, y, z, t are the independent variable. Sometimes that can be taken as dependent variable. If not, they taken u, they taken z as the independent variable. So don't confuse yourself. Okay. According to the question, they take different thing. But here, independent variable. Okay. All right. So denote the functions of several independent variables. So more than one, they say several. Okay. So you have to know these term words as well. Okay. Then the partial derivative u. So here you don't need to write this much of word. So they just simply using this u. That's why they say u is equal to this one. Okay. If it is say u, you have to know this is this one. So with respect to x. Okay. So what do you think? With respect to, we also abbreviated like this WRT. Okay. So they are saying we are only considering x. So as I said in our last yesterday class, I think I think hope everyone are doing MTM, no? Can you answer me? All the higher maths people are doing MTM, no? So because I'm talking that one also here sometimes. So can you answer me? All the higher maths people are doing? Yeah, okay. So hope it will be helpful. Good, good. Okay. So some things we taught there, no? So that's why I'm asking. Okay. So yesterday class, you remember in the last part I said f dash of x is equal to limit delta x tends to 0, f of x plus delta x minus fx divided by delta x, no? So this is talking about the ODE because our function f is a dependent variable which depend on one variable x. So when you are taking the derivative with respect to x, that's why they use this one. It means df over dx. Okay. So f dash x, which also this form. So this is equal to we are increment delta x to the fx, then subtracting that value fx, then divided by that whatever we are incremented, okay, delta x. Then we are taking the limit that delta x very small. It means tends to 0. Okay, that is what is the value. It's a definition for the differential equation. Likewise, we can define our partial differential equation as well. So this is a way of writing. So this is a partial derivative, so we use the DABA, okay? This U is dependent on X, Y, Z, T, no? There are four, okay? Four independent variables, but we are considering only X, okay? So if it's so, this will be the definition likewise. It means what? DABA U over DABA X. If it is DABA, only X we are considering. See the differences? That limit here for the delta X, they are taking H, okay? Everything else, okay. H, it is equal to, only see here, only X only changing by X. Here, only X. Here, X plus H, here, X. All the other terms are, we are taking as a concern. As I said in the elementary differential course, PDE considering other elements will be, sorry. Yeah. So, it's only considering the, if it is on with respect to x, all the other term will take as a constant, isn't it? So likewise, only increment in x, and all the other terms will be like that. This divided by whatever the increment, that will be h. Okay, this is a definition for the partial equation. I mean partial derivative with respect to x. Okay. Also, they say if the limit exists, if the we know in you may study in the limit class, the A level. Okay. If the limit exists only, it will be correct. Okay. There are situations the limit does not exist. So they say if the limit exists only, this definition has partial derivative will be this one. Okay. Likewise, can you write in your note? Okay. I mean, can you write the definition for, sorry, DABA U over DABA Y. What is DABA U over DABA Z? What is DABA U over DABA T? Can you write like this definition for all these three? I think you can send me the chat, but of course you can write and I will write later so you can correct your answer. Please everyone write down like this how you can write for the DABA U over DABA Y, DABA U over DABA Z, DABA U over DABA T. I'll give you 2 minutes. Can you all finish up? Okay. It's a simple thing. If you get the idea, it will be very easy. Okay. Have you all finished? Shall we check the answer? Please answer me. How many of you tried? Shall I answer you? Please be active, okay? If I ask any question, please answer quick as possible. That will be motivate me to go to the lecture. Very nice, okay? Okay, good. Very good. Okay, let me try the answer and you can check, okay? Because this answer is very long, so you can't type me in the chat. Okay, let's start our daba u over daba y. It's very simple, no? It's like a school level thing. So limit always exists. Limit h, we can set the h same, because delta x, delta y, delta z. If you take all these, if you prefer delta x, you can write, but we are taking everything as h, so no problem. Okay, so u of, so only y is changing. No, here x is changing, so x only increment. So x will be same. So one only thing is you have to keep this as a in order. Don't change the order. Okay, so y z comma t minus u x y z t divided by h. That's all. Very simple. So likewise, z, if you are taking z, this will be y, u, x, y, z plus h, comma t, that one, okay? So similar way, if it is t, only u, x, y, z, t only changing, okay? So very simple, okay? So if you write the correct thing, just correct it, okay? If it is any wrong, please correct yourself. I hope you don't get any wrongs, okay? Okay, let me continue. Okay, this is kind of a definition for the partial with respect to x, y, z. Okay, so just the increment. Likewise, I said, so we can't, use a pictorial view, but like this. Okay, if this x point, this is x delta x point, this is fx or ux. Okay, this is ux, this is ux plus delta x, and partial. The derivative means the slope. Okay, slope means, so this one can be taken like a Pythagoras way, daba y over daba x. Okay, so that is like that, tan theta is equal to delta y over delta x. So that is our idea of differential equation. So you can, I hope you heard these things in A level or something. Okay, it's not a problem. So that's the idea of definition. Okay, also you have to be provide this one also. Okay, provided this limit exists. Okay, let's continue. Next one, we'll use some notations. Okay, for easily. That's some books use this notation. I mean, it's a subscript notation. Subscript means I already told you, like this subscript. If it is like this, we call superscript. Okay, this is sub. So in the down part we say sub, if the up part we say superscript. Okay, so in subscript notation we use mostly in for the PDE for the easiness. Rather than writing this one, we use this one. See, daba u over daba x means ux. So it is a standard one. So wherever you use, everyone know. Okay, if it is ux, they know this is daba u over daba x. Nothing. Okay, everyone knows. So no problem. We can use this one or this one. Okay, so that's the notation we're gonna see. So let me, okay, take something. Okay, so let me explain this one. Okay, so you have to have, so daba u over daba x means what? What is the explanation of this one? Can you write me the chat? What is the idea of daba u over daba x in the word form? Can you write it? We already seen in the up there. So can you write it in Word? Yes, good. I got one answer. Can some more answers? You have to say yes, partial, okay? Partial derivative of u with respect to x, okay? That's how you have to answer me. Good. Okay, anyway, you got the idea. So, so we use the, subscript notation ux, okay? It means u with respect to x. So likewise, da by u or da by y can be written as u, whatever the dependent variable with respect to what. Okay, another one. See this one. What do you think this one? Okay, I'm having this problem again. Okay, our meeting will be end in 10 minutes, so you can join again like yesterday. Okay, I couldn't recover that thing. Okay, no problem. You can use the link again and join again. Okay. Okay, tell me what is the next one? What we call this one? From this one to this one, what we call? Can you write me the chat? In a word form, no, not like, partial derivative with respect to x. What is this one? What we are doing? Again, we are taking something, no? So what we can tell this one? Please answer me. What is the difference between this and this? What we are doing? Partial with respect to ux. Yes, but that is obvious. Tell me what is this one and this one? What is what is happening? Can you see the differences? This one to this one, what is happening? One more time differentiate. That is okay. Yeah, in the order, can you tell me in the order? You remember the order, no? But we will study now also. Yes, good. You get the idea now. Okay, this is the first order. We are taking one time. This is again we are taking now. So it will be second order, no? So that's the idea. Okay, that's what I am expecting you. Okay, no problem. So you get the idea. So we are taking again. Yes, okay. So we are taking again the partial derivative with respect to x. Okay. So how you can denote that one? So for example, I said the first derivatives are denoting this way: ux, ux, uy. Sorry. So how about this one to notate? See the things. So it means da bar over da bar x of da bar u over da bar x. Okay, it means what? This element can be a partial derivative with respect to x. So it can be written as uh, I think I told you already also. Likewise, in the ODE, we use, for example, du over dx of du over dx. So we use the notation, this one, no, d square du over dx square. Likewise, here also we use da bar square du over da bar x square. So how you can denote in the subscript notation? Already we have x. Again one x. So this is the first order. This is the second order. So you have to be careful, okay? So this one for first, this one for second. So keep it in your mind. Same wise, you can write all the other things. Okay, why also like that. Okay, one more. Are you all clear? If you have any doubts or anything, you can chat also. Okay, so I can answer you. Okay, now that is obvious. So with respect to, second derivative with respect to x and y, that is okay. So see this one. What do you think? see carefully what is happening. Can you tell me in word what you are seeing differently? From this, you can understand this one. Tell me what's happening. In a word, what do you understand? Yes, first differentiate u with respect to x, and again, yeah, good. Okay. Yes. First, okay, tell me first what is happening first. 123, can you check the idea? First, what's happening? Daba u over daba y, no? So this is the first one. Okay. Yes, good. Okay, if you understand, that's fine. So it means you have to know, we know that, order, board mark, all those things, no? So what is the B means? Can you tell me what is the B means in the board mass, the school level, order of calculations? What is the B means? Yes, good. Bracket, no? So bracket. So you had to, likewise, you have to consider the bracket first. Okay? So first of all, you have to consider the bracket, then only this going, this one. So likewise, uy is the first one. Then we are taking with respect to x. So it means daba over daba x. Okay, only there's one things you have to consider. This one, daba squared u over daba x daba y. Okay, so I think I told you earlier that is wrong. Okay, this one is the second, this one is the first. Okay, let me check. Okay, this one, what's happening? So you have, when you are right, okay, I'll erase and write again. Okay, so what is happening is, earlier also, so daba over daba x of daba u over daba y. So when you are writing daba squared, this is also fine, okay? But in this, you have to write in a order, daba x and daba y, okay? So in here, we can't consider that one. Here, carefully consider. So we have to put this inside the bracket like that, daba squared u, and we are pushing this one out there, and we are putting daba x first. Okay, so this is the second, this is the first. So likewise, you can, here we don't need to consider that one, but here you have to be careful. Okay, but most of the time, what do you think? This one, daba over daba y of daba u over daba x. Can you write in your notebook what will be the answer? Likewise, this one. Also, the subscript notation also will be according to this one. Okay, don't consider this one. You write this one, x, y. Okay, so in this way only you have to consider x, y. So can you write for this one, how this comes, and the subscript notation also? I don't know, you can see clearly. Okay, so this is there. Okay, you can check this one, right? Daba u over daba y of daba u over daba x. So how will be the next term and the subscriptions? So this will be in the this order, 2, 1. Okay. So how will be the answer? So daba squared u over, what is here? It is pushing inside, no? So daba y over daba x. So when you are writing in the, yeah, let me see the answers. Okay, good. Okay, good, fine. So when you are writing in the, subscription notation, it will be this one first, this one. You don't need to check you write in this order, that will be fine. But when you are studying this one, we have to study this way, okay? But most of the time, I mean, uxy will be uyx in most of the examples, but don't take every time it is correct, okay? Sometimes it may not equal to. So according to the example, it may differ, okay? Sometimes it may, if you take first with respect to x, then if you take the y, and if you take the y and then you take the x, sometime maybe according to the example, it may be equal or not equal, okay? So, but you have to know what it is really happening, okay? So please consider this one.